Hi everybody, today let's look at how to get the first derivative by using the formula. Okay, let's look at the first formula. Y equal to k. It means that y equal to a constant. For example, y equal to 3, y equal to -1/2, y equal to 0.5. All of this will give you the same answer when you want to find their first derivative, dy by dx. dy by dx for these three are actually the same, which is equal to 0. So this dy dx is equal to 0. Okay, let's look at the second formula. Y equal to ax raised to the power of n. For example, y equal to 3x raised to the power of 2. How do we get the first derivative? By using the formula. According to this formula, dy dx is equal to, bring the 3 go down, bring the power here, which is 2, go down here. Okay, copy this, 3, and copy the x as well. And remember, the power here, you have to minus 1, 2 minus 1. Okay, so this is the answer for the first derivative of that function. 2, 3, you will get 6, and x, 2 minus 1 is equal to 1. You don't have to write 1 here. Okay, so by using the formula, we can actually get the first derivative of a function easily and also faster compared with the first principle. If you forget about this one, you actually can use this second formula to help you to get the answer. For example, this one. Let's say I forgot about what's the first derivative of this. I don't know how to find this one. So I can assume that there is an x here, which is raised to the power of 0. Because x raised to the power of 0 is equal to 1, right? So 8 times 1 is still the same thing. Now, dy dx. Now, I'm going to use this formula to help me to get the answer for this questions. Bring the 0 go down, copy the 8, copy the x, and the power you have to minus 1, 0 minus 1. But this doesn't matter. When you have a 0 multiplied by something, you know that the answer will be equal to 0, right? So in case you forget about this, you can use this one to help you recall back this formula. Okay, now let's try part C. Y equal to 5x raised to the power of 3. dy dx. 3 you bring down here. Copy the 5, copy the x, and the power every time you need to minus 1, 3 minus 1. Okay, 3, 5 will give you 15, and this x raised to the power of 2. But in the exam, actually you don't have to do it this way. Once you have been very familiar with this formula, you can actually do it this way. Y equal to 5x raised to the power of 3, dy dx. You just calculate mentally. 3 bring down here, multiply by 5, you will actually get 15, right? Copy the x, power always minus 1, you get 2. Straight away, you get the final answer here. Okay, let's try D. Y equal to 3 over x raised to the power of 2. For this type of questions, the first step, we change the way of writing this. We don't want to put the x squared at the bottom as the denominator of a fractions. We change it become 3x raised to the power of -2. This one you learned before. I hope that you still remember. Now, this is already in this form. We can start to use a formula to help us get the first derivative. dy dx is equal to -2, you bring down here, copy the 3, copy the x, and the power, remember the minus 1. Negative 2, copy first, minus 1. So eventually you will have negative 6, negative 2 times 3, you get negative 6, and this is x raised to the power of negative 3. But we don't stop here, we do one more step, change back to this form, negative 6 over x power 3. Okay, so this is the final answer for part D. Let's look at example 5. f of x is equal to 2x power 3. f of x is equal to 2x raised to the power of 3. We want to find, okay, f prime, it means that the first derivative. If you have y, you differentiate it, you will get dy by dx. If you have f of x, you differentiate it. We do not write dy by dx, we write f prime x. But they are the same thing. They are the gradient function is a function that help us to get the gradient of the tangent. Okay, now let me find the first derivative first. Still remember the formula? 3 you bring down. But now I will do it a little bit faster. Just calculate mentally. 3 bring down times by times with 2. You will actually get 6, right? 3, 2, you get 6. Copy the x. 3, the power here always minus 1. 3 minus 1, you get 2. Okay, so this is the first derivative. Now we are going to find f primes of negative 1 and f prime of 1 over 2. The first derivative is equal to 6x power 2. So f primes of negative 1 is actually means that we need to bring the negative 1 inside here. If you put negative 1 here, here you have to put negative 1 as well. 6 negative 1 square. Okay, so you will get negative 1, you square it, you will get actually positive. 6 times 1 is equal to 6. What does this mean? It means that when the x is equal to negative 1, the gradient of the tangent at that point is actually equal to 6. Let me show you here. Now I have a function which is y equal to 2x power 3. This is a function, this is a graph. The point negative 1, negative 2. When the x is equal to negative 1, the y will be equal to negative 2. But now we only focus on the x. Just now we got the answer which is equal to 6, right? The 6 is actually means that the gradient of the tangent of this curve at this point. This is a tangent of this curve, y equal to 2x cubed at the point A. The coordinate is negative 1, negative 2. So you look at this, y equal to 6x plus 3, plus 4. The gradient is equal to 6. So actually what we got here is actually gradient of the tangent. Let's try another one. F primes of 1 over 2. This is 1 over 2, so we have to put 1 over 2 over here. 6 times 1 over 2 square. 6 times 1 over 4. So you simplify it, you will actually divide it by 2, divided by 2, 3 over 2. Or if you want to write 1.5, it's the same thing. So this means that the tangent of this curve when at the point when x is equal to 1 over 2, the gradient is 1.5 or 3 over 2. Okay, let me show you here. When the x is equal to negative 1 over 2 or negative 0.5, the y is equal to negative 0.25. The tangent at this point is this one. You look at the equation here. The gradient of this tangent is 1.5. Okay, so now you you know what you are doing. This is actually the gradient of tangents at that point. For this type of questions, actually you can use your calculator to help you to check the answer. So you just press this shift and press this. You just key in 2x power 3, 2x power 3, and then key in the value of x. Okay, let's try this one. 1 over 2. 1 over 2. Just press equal. You will get the answer 3 over 2. Let's try another questions. Okay, this one. Differentiate the expression. Okay, we just let y equal to this whole thing. 3x plus 2, 2x squared minus 5. So in this case, I am going to expand it first. Y equal to 3x times this one, 6x power 3, and this time this one, negative 15x, positive plus 4x squared, and the last one will give us negative 10. Positive 2 times negative 5 will give you negative 10. Okay, now if you want to find the differentiation, you can start now. If you don't want, you can just arrange it nicely first. X squared, then followed by x cubed, followed by x squared, followed by x, and followed by the constant. Okay, now we can start to find the dy dx. If you have a few terms like this, separated by plus and minus sign, then it is actually very easy for us to find the differentiation. You just differentiate every single term here, just using the formula that I told just now. Okay, let me show you here. First, 3 bring down times the 6. You will get 18. Copy the x. And the power here always minus 1. 3 minus 1, you will get 2. Okay, here do the same thing. Plus 2 times 4, you will get 8. Copy the x. Power minus 1. 2 minus 1, you actually 1. 1, you don't have to write 1. Okay, so how about this one? Okay, let me show you here. If let's say I have y equal to 15x, dy dx is equal to 15. We don't have x anymore. Why? Now you have a 1 here, right? 1 bring down times 15, you actually get 15, correct? Copy the x, and this is 1. 1 minus 1. Remember, I told you just now, the power here always need to minus 1. That's why you will get 15 times x power 0. X power 0 is actually equal to 1. That's why we only write 15. We don't have to write 1 here. So you differentiate it, this term, you will get negative 15. How about this? I hope that you still remember just now I told you 1. You differentiate a constant, you get 0. Okay, so this is the answer for this questions. 18x squared plus 8x minus 15. Let's try the next one. Okay, how to find the first derivative of this? Let me copy first. F of x is equal to 6x cubed minus 4x plus 3 over x. Okay, remember, don't do it this way. Now, I'm going to show you the solution which is not correct one. Some students might do it this way. Differentiate this one, you get 18x squared. Differentiate this one, negative 4. Differentiate this one, you will get 0. And then differentiate this one, you get 1. No, this is not correct. You cannot do it this way. So when you have something like this, u over v, we actually have another formula that I'm going to show you next in the next example, how to get the first derivative of this type of function. But in this case, I'm not going to use that formula first, Because this one we can just separate them into a few terms. 6x cubed minus 4x plus 3 divided by x. It means that every single term here, they share the same denominator, which is equal to x. I can break them into this way, write them into this way. Okay, and then we try to simplify them. 6x squared minus 4 plus 3x negative 1. Okay, now I have a few terms here separated by negative or separated by the minus sign and plus sign. Then it will be very easy for us to do the first, for us to find the first derivative. We just differentiate every single term here using the formula that we learned just now. Do bring down times with the 6, you will get 12. X copy, 2 minus 1, you get 1. You don't have right 1 here. And if you have a number, just a number, you differentiate it, you get 0, right? How about this one? When you have a negative power, you have to be more careful. Negative 1 times positive 3, you actually get negative 3, not positive 3, okay? X copy, and the power, you always need to minus 1. Negative 1 minus 1, you get negative 2. So let me change back to this form. 12x minus 3 over x squared. Okay, so this is the answer for this question. Okay, now let's look at this example. This is what I mentioned just now, u over v. Let y equal to 1 plus 4x. We want to find the first derivative. Differentiate this with respect to x. X squared minus 2. Okay, you cannot do it this way. Differentiate 1, differentiate 4, differentiate x squared, differentiate 2 is not correct. So we need to use this formula. This formula looks complicated. We actually can okay, you can do it this way. First, I will suggest you to do it this way first, and after you have been very familiar with it, you can do it another way. Okay, let u equal to 1 plus 4x. Then you find du dx, which is equal to, differentiate this one, you get 0. Differentiate this term, you will get 4, right? And same thing, v equal to x squared minus 2. Now we find dv dx. Differentiate this, you will get 2x. Differentiate a number here, you will get 0. Now you have all the things that we need here. You can start to plug in into this formula. According to this formula, if you have y is equal to u divided by v, then the dy dx is equal to v, copy this one first, x squared minus 2 times with du dx, 4, minus, copy u, which is this, multiplied by dv dx, which is 2x, over the whole thing here, the v, this whole thing, you need to square it. Okay, but don't leave our answer like this. We try to simplify it, make it simpler. Do some expansion here. 4 times x squared, 4 times negative 2. You will get 4x squared minus 8. Here do the same thing, do some expansion. Negative 2x, negative 4 to 8 square. Okay, here you don't have to expand it, you just keep like this. For x squared minus 8x squared, you will get negative 4x squared. Here you will get negative 2x, here negative 8 over x squared minus 2 raised to the power of 2. Okay, so you can leave your answer like this. If you want to factorize it, you can bring the negative 2 go out. Then here will be 2x squared plus x plus 4. When you factorize the negative number, go out, all the sign here you will change. Okay, correct. So this is the final answer. So once you have been very familiar with this type of differentiation, you don't have to let u equal to this, v equal to this. You can do it straight away from go here. So let me show you here. Normally, I will just do it this way. Find dy dx, right? Okay, I remember this way. Copy the denominator first, then differentiate this one. Differentiate this, you will get 0. Differentiate this one, you get 4. Then minus. Copy the numerator, differentiate the denominator. You get 2x over the whole thing here, denominator, you need to square it. We are actually doing this, but we just do not show the let v equal to this, then dv dx, u equal to this, then du dx. We straight away go to here. Okay, then the next step you can try to continue, you get exactly the same thing. Okay, let me repeat again. Copy the numerator, copy the denominator, then differentiate this one, minus, copy the numerator, differentiate this one, and then over the, I forgot to write a square here. The whole thing you need to square it, just like what we did just now. Okay, so you can try to continue, you will get exactly the same answer. Remember this one, don't mess up with another one. So this formula that I told just now is for u over v. Later we are going to learn another formula, y is equal to u times v. That we need to use another formula. Okay, now let's try this one. Now this is power 4. If you want to expand it a little bit hard, right? If let's say you have just a number like, for example, 3x squared minus 5 raised to the power of 2. In this case, you can actually expand them, then differentiate term by terms. If you don't want, you can use this formula as well. But when you come to raised to the power of 3, 4, right? You want to expand it, it will take a longer time. Normally, we do not expand it. We will just use this formula. So how to get the answer for this one? Let me show you here. Part A. Y equal to 3x squared minus 5 raised to the power of 4. So we just let this whole thing be u. Let u equal to 3x squared minus 5. Then we find du dx. This is equal du dx, right? This is not y, so that's why here I do not write dy dx, but du dx. 2 times 3, you get 6x power. 2 minus 1, you get 1. Differentiate a number, you will get, differentiate a constant, you get 0. So this is du dx. Now, since I have let this one be u, right? Now, here will become u. Y is equal to u raised to the power of 4. Since this is u, I will need to find dy du. 4 bring down here, times the u, power minus 1, you get 3. Now I have du dx and I have dy dx. I'm going to combine these two to help me to get dy dx. Okay, now I'm going to use the change rules. dy du times du dx. Change rules. So eventually you will get dy dx. dy du is 4u cubed. U is actually this one, right? So I'm going to write this inside here. Okay, times du dx, which is 6x. Then this will give you 4, 6, 24 x, 3x squared minus 5 raised to the power of 3. Okay, so this is the answer of this quotient. But normally, when we have been very familiar with this, we don't have to do it this way actually. Normally I do it this way. Y equal to 3x squared minus 5 raised to the power of 4. So I just straight away go to dy dx. So just think this way. Assume this is a big X. Okay, don't touch anything here. Just assume this is a big X. So how do we differentiate this? I bring the 4 go down, right? X copy, then power minus 1, right? Do exactly the same thing. 4 go down. Copy this whole thing. Don't touch, don't change anything here. Power minus 1, right? Okay, become 3. And then you have to do extra one thing. Differentiate this inside one. So now ignore about the parentheses and also power 4. Just look at this. Differentiate this whole thing. You will get 6. 2 times 3, you get 6x, right? 6x. Differentiate the constant, you get 0. And then you just multiply 4 by 6x, 24x, 3x squared minus 5 raised to the power of 3. You get exactly the same answer. Okay, now let's try the last one. So this is what I mentioned you just now, y equal to uv. So we are going to use this formula. So don't get confused with this formula. This is for divide and this is for multiplication. I'll multiply. So this formula is actually doing copy. Okay, that's this u, this v. Copy this one, then differentiate this one, right? And then plus copy this one, differentiate this one. So at the beginning, you can do like this, like what we did for this one. Let u equal to 3x minus 1 power 3. V equal to 1 plus 2x power 2. And you find a du dx. Du dx. Okay, hope that you still remember this, what we did just now. Assume this whole thing x. Don't touch anything. Then the 3 bring down here. Copy exactly what we see here. Power u minus 1, you will get 2. And don't stop. We have to differentiate inside 1. You will get 3. And here we actually give you 9. 3x minus 1 squared. Here, do the same thing. dv dx. Assume this is a big X. Okay, don't touch anything here. Don't change anything here. 2 you bring down here. Copy exactly what we see here. Power minus 1. You will get 1. You don't have to write 1 here. And don't stop yet. You have to differentiate this 1 plus 2x. You will get 2. Then this will give you 4, 1 plus 2x. Okay, now you have du dx, you have dv dx, and you have uv. Everything you just plug in here and continue doing it. But personally, I do not do it this way. I like to do it like this. Y equal to 3x minus 1. 3x minus 1 raised to the power of 3 times 1 plus 2x power 2. Okay, so I just remember it this way. Copy this. Differentiate this to bring down 1 plus 2x power minus 1, right? Don't stop yet. You have to differentiate inside here. You get 2. Then plus, don't get confused, This one is for this one we use minus, this one we use plus. Okay, just now we copy this, differentiate this, right? Now we change. Copy this, differentiate another one. Copy this. 1 plus 2x raised to the power of 2. And differentiate this, you bring down the 3. Copy the whole thing. Minus 1, 3 minus 1 you get 2. And don't stop yet. You still need to differentiate inside here. 3x minus 1, you differentiate it, you get 3. Okay, let's continue. So here you will get 4. 3x minus 1 raised to the power of 3. And 1 plus 2x. Okay, let me double check. 2 you will get 4. 3x minus 1 raised to the power of 3. 1 plus 2x. So how about here? 3 you will get 9. Then we have 3x minus 1 raised to the power of 2. And 1 plus 2x raised to the power of 2. Oh, sorry, this is not correct. The parentheses should be here. Okay, so now next we try to simplify it or do some factorization and so on. So here I have 3x minus 1 power 3. Here I have 3x minus 1 power 2. So I just bring the 3x minus 1 power 2, factorize it out. And here I have 1 plus 2x power 1. I have 1 plus 2x power 2. 1 plus 2x. I just factorize the 1 plus 2x out. Okay. Now I have to think. This need to multiply by what? So that I will get back this. I need a 4. And this is 3x minus 1 power 3. This is only power 2. I need another one. 3x minus 1. And this is power 1. Power 1, you don't have to write anything here. Plus 9, you need to copy. Here is 3x minus 1 power 2. Here is already power 2. So we don't have to write anything here. How about here? This is 1 plus 2x power 2. This is 1 plus 2x power 1. It means that we need another one. Okay, so here you don't have to do anything. You just copy 3x minus 1 square, 1 plus 2x. Here we just do some expansion, then we simplify it. 4, 3, you get 12x, negative 4. 9 times 1, 9 times 2, you will get 18x. Okay, so 12x plus, you will plus 18x, you will get 30x. And this will give you 5. Negative 4 plus 9, you will give you 5. So if you want to factorize further, here you can bring 5 out, right? You can factorize 5 out. So normally we do not write number here, we just bring the 5, go to here. Okay, since I factorize the 5 go out here, I need to write 6x. 5, 6, you get 30. Here I need 5. I need to write 1. 5 times 1, you get 5. Okay, so this is our final answer. Let me double check. Oops, I think I make a mistake here. Okay, correct, no mistake. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye.